Cramped conditions in the Rising Star cave system and the Dinaledi chamber where the Homo naledi fossils were found begged by paleoanthropology standards for unique mapping and excavation documentation treatment. So Ashley Kruger and his colleagues decided on going 3D rather uniquely.
We used a lot of new techniques to map and visualize this chamber, and as well as the Rising Star cave. And there was a lot of new technologies that we had to amalgamate together, so we had to connect them all together. We had drone photogrammetry, which is flying an unmanned aerial vehicle. We also had laser scans, and we had white light source scans inside the chamber, and we had to link all of these together, and that was very challenging because it's never really been done before.
Only the petite underground astronauts could go down into the Dinaledi chamber. But scientists like Professor Lee Berger above ground also needed to look at the excavations approximately 38 meters below the surface. Once again, the 3D technology was handy.
The most exciting part of this technology use was really seeing the excavations come to life above ground. By creating a 3D model of the excavation areas, we were able to take those scans up to the surface in almost real time. So other people above ground could give suggestions to excavators on how to proceed, with it all in 3D. The handout scanner is really important, and it was an important tool for us because it's very small. So of course it can fit down the narrow chute, go through that 18 centimeter gap, and it could fit into the Dinaledi chamber. But it was also important because it captures very high resolution images. And so we had a very accurate and high resolution 3D model of the excavation areas, and that's always important because we never know what kind of data we'll use much later on.
But the high-tech didn't quite conquer the chute leading into the Dinaledi chamber.
The chute leading down to the chamber was impossible to scan because of its really small nature, and there's no scanner around today that can actually scan that area. And so we had to use a little bit more primitive, if you want to call it that, laser distance meter, which was able to give us known points above the chute and known points within the Dinaledi chamber, so that we could link the chamber to the rest of the cave system. So we don't have a visualization of the actual chute, but we do have a very accurate placement of it.
Being the largest hominin find in Africa, the Homo naledi fossils will keep scientists busy for a long time to come. The 3D framework and map will be useful.
And so once we develop the excavations and the excavations are ongoing, we can still plug them into this larger framework. So in terms of the work that we've done here, the way forward is to look at and analyze the 3D models of the excavation area and see if they can tell us something about the Homo naledi assemblage. Can they tell us something about Homo naledi's life, and more importantly, something about its death?
In the meantime, scientists working on dating the Homo naledi fossils are currently consolidating results of all tests. Marise de Klerk, Joburg Today.